Hey Level 3s, and welcome back to 3.4 Atomic Structure and Bonding and Thermodynamics. This is Lesson 15, Part C. So the only thing I'm doing in this session is going through examples with you. There'll be 6 in total. So hydrazine is often used as a rocket fuel. When liquid hydrazine undergoes combustion, it forms nitrogen and water, and here's the equation. The enthalpy of combustion is negative 624 kilojoules per mole, meaning that it is exothermic. Okay. Explain why hydrazine readily burns in oxygen. Readily burns is a different way of saying it is a spontaneous reaction. Okay, so your answer should include both enthalpy and entropy changes. So I'm going to go through this with you verbally, okay, and then we can continue from there. So what you'll see is on the left-hand side of the equation, you have got a liquid and a gas, and then on the right-hand side of the equation, you've got 2 gases. So you're actually going from, or actually 3 gases, sorry. You're going from liquid to gas. Gaseous particles are able to move around more because they have greater kinetic energy, and therefore there will be greater disorder and greater entropy. There is a second factor here that you can discuss when talking about entropy of the system, and that is the fact that you go from 1 plus 1, 2 reactant moles to 1 plus 2 makes 3. So there's also an increase in the number of moles. Okay, and if there are more particles, there are more ways that they can arrange themselves, therefore increasing the entropy and therefore increasing the entropy of the system for a second reason. So there are 2 reasons why entropy of the system is going up. So S is increasing in this example. The other thing is that it is an exothermic reaction. So whenever we think enthalpy, we can think about the surroundings. So because this reaction is exothermic, that means heat energy is being released to the surroundings. The surrounding particles move around more because they've gained kinetic energy. And this means because they're moving more, there'll be greater disorder and greater entropy. So both entropy of the system and both entropy of the surroundings is increasing, okay, which means that this reaction is spontaneous. Okay, now you can answer it just like that. So talk about entropy of the system, talk about entropy of the surroundings, and then state because they are both positive, the reaction will be spontaneous. The alternative way of deciding whether the reaction is spontaneous is by doing Gibbs free energy. Okay, and Gibbs free energy is H minus S. So if this is negative, okay, and the enthalpy is positive, you always get a negative value, which also means that the reaction is spontaneous. I have typed this out for you, and here is the answer here. Okay, I'm just going to try and move the... There we go. Oops. Sorry, back. Hopefully it won't let me go any higher, unfortunately, but entropy of the surroundings, okay, as it's an exothermic reaction, okay, this releases heat energy to the surroundings, the particles gain kinetic energy, move more, and disorder increases. So we've said that. Entropy of the system, 3 gas molecules on the products compared to 2 on the reactants. More particles means there are more ways to arrange themselves, increasing disorder. The system also goes from a liquid reactant to a gas product. Gases have higher kinetic energy, higher disorder, entropy increase. Hopefully that makes sense. As both the system and the surroundings gain entropy, the reaction is spontaneous, or you could alternatively use this equation here to show that G was negative. Any questions, please let me know on Teams. Here's another question. Methanol evaporates easily at room temperature. However, its enthalpy of vaporization is endothermic. Elaborate on this statement using your understanding of enthalpy and entropy changes. So evaporation of methanol, so methanol is CH3OH. Evaporation is going from liquid to gas, so CH3OH gas. Okay, so, and this is, it says that this is endothermic, a positive value. So how can this reaction be spontaneous if it is endothermic, because remember, most reactions that are spontaneous are exothermic. So the only way that it's possible is if there is a large increase in entropy. And the reason why there is a large increase in entropy, as you can see here, it's 1 mole of methanol forming 1 mole of methanol, so the same number of particles, but there's a state change. We know gas particles have a much greater kinetic energy because they move far more, therefore so much greater disorder, which increases the entropy. So the entropy of the system is increasing, despite the entropy of the surroundings is decreasing, being an endothermic reaction. So the only way that this is possible is that to get a negative G, okay, by doing H minus S, is the fact that the S must be having a much bigger influence here than the H to produce a negative value. And here is my model answer. Okay, as methanol needs to absorb heat energy in order to evaporate, the process is endothermic and has a positive H value. This means surrounding particles have less kinetic energy, move slower, decreasing the disorder in entropy. So entropy of the surroundings decreases because it's endothermic. As all the reactants are liquid and the products are gaseous, the increase in disorder in entropy, or the entropy of the system, increases. Okay, as the reaction is spontaneous and both entropy and enthalpy are positive, to produce a negative Gibbs free energy, the entropy value must be bigger, which in other words means entropy driven. Hopefully that makes sense. Another example, ammonium nitrate is used in cold packs to relieve symptoms of sports injuries. The dissolving of solid crystals of ammonium nitrate shown in the equation below is spontaneous despite it being endothermic. Explain why in terms of entropy and enthalpy. So this here, we can see that the entropy of the system is going up. And why is the entropy of the system going up? Okay, well, there are two reasons. One is that it's going from 1 mole to 2 moles, okay? So there's more particles being produced, so therefore there's more ways they can arrange themselves, greater disorder. The second reason is because it's going from solid, which is ordered, to aqueous, which are able to move around more, and therefore there's greater disorder. So there are two reasons as to why ammonium nitrate shows an increase in entropy. Okay, the second thing that we need to talk about is the fact that it said it was endothermic. Because it's endothermic, the entropy of the surroundings is going to go down. Okay, and the entropy of the surroundings is going to go down because endothermic reactions absorb heat energy. So surrounding particles are going to be moving slower, less kinetic energy, less disorder. So we've got an increase in entropy of the system. Okay, which we've explained here, a decrease of entropy of surroundings. However, it tells you in the question that it's still spontaneous. So how can it still be spontaneous? We've got a positive S and we've got a positive H, and the only way that's possible to get a G, which is H minus S, it must be that if these are both positive, the S must be a bigger value in order to produce a negative G. So this reaction is entropy driven and the entropy is having the greater effect. Here's my answer. Okay, so you can pause and have a read if that makes sense. Okay, question 3. This is kind of continued. Oh no, sorry, it's a different one. Ammonium nitrate dissociates in an endothermic reaction in the equation below. It says tick the following. So this reaction, the entropy of the system is going from 1 mole to 2 gaseous moles. So that's an increase in entropy. It's also going from solid to gaseous. Gaseous particles move around more with more energy, greater disorder. So that again confirms an increase in entropy. So the entropy of the system increases. It said it was an endothermic reaction. So we know endothermic reactions absorb heat energy, which means the surrounding particles will be moving slower with less kinetic energy. Therefore, there'll be less disorder and entropy of the surroundings will decrease. Okay, and I've just explained all that. Okay, why does NaCl rapidly dissolve in water even though the process is slightly endothermic? You'll kind of see that they often ask like, oh, it's endothermic, but it's still spontaneous. Explained. They like to do this a lot. So let's start with the endothermic factor. Endothermic factor reactions mean that the entropy of the surroundings will go down. And the reason why entropy of the surroundings will go down is because endothermic reactions absorb heat energy. Therefore, the surrounding particles will move around less. With less kinetic energy, there'll be less disorder and less entropy. Okay, so entropy of the surroundings goes down. Entropy of the system is going up. You're going from 1 mole to 2 moles. So more particles mean there are more ways to arrange themselves. And it's also going from solid to aqueous. Aqueous particles can move around more, and therefore there's greater disorder. So system is increasing in entropy. So how is it possible to get this reaction happening? Well, to get a negative G, which is H minus S, the only way G can be negative if H is positive is that S must be a bigger value. So therefore, we would say this reaction is entropy driven. And please feel free to read this answer and ask me any questions. Last one, and then I'll leave you to it. Explain why the sublimation of iodine is spontaneous, even though the enthalpy of sublimation is a positive value. Sublimation is when you go from solid to gas. So this is the equation here. Okay, they're saying is a positive value the enthalpy. So that means that it's an endothermic reaction. We know that always endothermic reactions mean that the surrounding particles are decreasing in entropy. And that's because endothermic reactions absorb heat energy. So surrounding particles move around less with less kinetic energy, less disorder, and so entropy decreases. The entropy of surroundings decreases. Now, entropy of the system is going to increase because it's going from solid to gas. Gaseous particles have more kinetic energy, move around more, greater disorder, greater entropy. So greater entropy of system is increasing. So how is it possible to get a spontaneous reaction? Well, a spontaneous reaction means a negative delta G, so H minus S. So if H is positive, S must be a bigger value, and so this is also entropy driven. That is the end of your topic. Okay, here's the final answer there. Please feel free to read it, and we'll be doing more problems together in class about this. Well done, team. That's the end of this topic.